Hi, welcome to our channel. My name is Travis Group from the RAFC Year 2 class. Today we will be exploring the important role of instruments used in balancing air and water systems. These systems are essential in buildings, industries, and environmental control. They help maintain safety, comfort, and efficiency. In this video, we will explain what system balancing is, why it is necessary, and how specific instruments help ensure that air and water flow at the correct rates. The instruments we will be focusing on include the manometer, anemometer, flow hood, and psychrometer. Each of these tools has a unique function when it comes to measuring pressure, airflow, and analyzing humidity and temperature. By the end of this video, you'll have a clear understanding of how these instruments work and why they are essential in air and water systems.
System balancing is the process of adjusting an air or water distribution system so that the correct amount of air or water reaches each part of the system. This ensures every room or zone to receive the flow that it was designed to have. System balancing is necessary because without it, some areas may receive too much or too little. This can cause problems such as uneven temperature, poor ventilation, noise, discomfort, and increased wear on equipment. An unbalanced system also uses more energy, as pumps and fans have to work harder to compensate for incorrect flow rates. Proper system balancing improves overall performance by ensuring the system operates as designed. Balanced systems are more efficient, reliable, and comfortable.
The manometer is a diagnostic instrument used in HVAC system to measure air or gas pressure. It is commonly used to check static pressure and verify proper airflow, which is essential for efficient heating and cooling performance.
An anemometer, also known as an anemometer, is used to accurately measure wind speeds. There are various types of anemometers, but the thermal or hot air anemometer is the type used in HVAC industry. It is most often used for air balancing. An anemometer measures air velocity, speed of airflow in ducts, grills, and diffusers. Simple use of an anemometer on a split air condition unit is to measure by a CFM, right? So you're calculating the return air, right? Then the supply air, right? In order to calculate these values accurately, must at least have 4 inches of space from the ceiling to the unit. How to use an anemometer step by step. Firstly, turn on the anemometer. Secondly, place the sensor directly in the airflow part. Thirdly, hold it steady for stable reading. Fourth, record the air velocity, feet per minute or meters per second. Multiply velocity by duct area to calculate airflow. Lastly, we adjust the dampers to increase or decrease airflow as needed.
The psychrometer is used to measure dry bulb temperature, wet bulb temperature, and relative humidity. These measurements help determine important air properties such as dew point and enthalpy, which are essential for assessing comfort and HVAC system performance. A traditional psychrometer consists of 2 thermometers connected by a swivel. One measures a dry bulb temperature, while the other has a wetted wick covering the bulb. As air passes over the wet bulb, evaporation causes cooling. The difference between the 2 temperatures depends on the humidity level. Higher humidity results in a smaller temperature difference, with both readings becoming nearly equal as relative humidity approaches 100%. Firstly, remove the cap on the psychrometer. Right. power on the digital cyclometer, or moisten the wick for an analog unit. Place the probe or the instrument in the airstream. Allow readings to stabilize. And record dry bulb, wet bulb, and relative humidity values. Compare results with comfort standards and system design requirements, and adjust system operation if necessary.
Flow hoods are devices designed to control and measure airflow by maintaining clean, controlled air movement. In HVAC applications, a flow hood, also called a capture hood, is a portable instrument used to measure airflow from supply diffusers and return gauge during system balancing and commissioning. In clean environments, flow hoods may also use HEPA or ULPA filtration to provide contaminant-free airflow that protects sensitive products and processes. Flow hoods are essential tools for accurate airflow measurement and for maintaining safe, controlled air conditions during HVAC balancing and specialized clean air operations. Functions and types. Airflow measurement accurately captures and measures air volume from registers and gauges. Product protection reduces contamination by directly particles away from the work area. And directional flow provides smooth, steady airflow from consistent performances. Vertical flow filtered air moves downward from the top and exits at the front of the rear. Horizontal flow air moves from the back towards the front, shielding the product from the user.
My name is Chavez.
My name is Dario.
And this is the end of our video.